Hi, Faith. I got your assignment here, and this would be very similar to some of the stuff that we did in data management, but it's been a while for you since that course, so it might take a little while to come back. When you are doing mean and median and standard deviation calculations, then the first thing you need is the mean. And so I think there's 10 numbers here. Yep. So what we're going to do is we're going to find the sum of these 10 numbers. We're going to add them all up. And then we're going to divide by the number of numbers, which is 10 in this case. And that's going to give us our mean value. And so that's our m that we're looking for up here. So whatever that is, let's just say for sake of argument that it's 25. The next step in the chart is to go to the second column and take your raw x value, which was 35, and subtract the mean, which is 25. And you do that all the way down, and even if it turns out to be a negative, that's okay. So you're going to get all of these values, okay? And so in the first case, we would get 10. In the second case, we would get negative 8, and you would just do that all the way down. On the right-hand column, in the third column, it's just x minus m in brackets all squared. What that's telling you to do is take the answer you got in the previous column and square it. And so here I'd get 10 squared, and that would be 100. And then I would get negative 8 squared, and it's really important for you to put that negative 8 in brackets like that, because it's got to be negative times a negative. And that would give us positive 64, and so on. So the reason that we're doing the squaring is actually to get rid of the negative values so that at the end we have a whole bunch of positive values, and we're going to sum those now. We're going to add all 10 of those numbers together. We're going to divide that by 10, and then we're going to take the square root of our answer, and that's going to give us the standard deviation. And so the mean of x is going to be what we get here. The median is going to be the middle number, so you would write them in order. So start with the lowest, like 13, 17, and so on. And so in this case, because there's 10 numbers in our set, we're going to take the halfway point between the fifth number and the sixth number in our list. The mode is the most frequent, and we think 30 occurs twice in this list, so that's our mode. The sum of the squared differences from the mean, that's the sum here that you get when you square all of those numbers, whatever that adds up to. The variance is your standard deviation squared. So the variance is equal to the sum of all of your x minus mean squared over 10. That's the variance. When you take the square root of that number, that's your standard deviation. So that's the answer for the next question for 1F. Let's just see if there's anything else down here. No, I think that finishes off that page. All right, the next few questions are asking you about changes to the data set that they gave you to begin with. So if we changed number 35, which is one of our highest numbers, if not our highest number, if we changed it to 70, the mean is going to become larger. So you would take the 35 out of your list and you would put the 70 in, and then you would divide by 10 again. And so you're going to increase your mean by 3.5 because you're putting in 35 more in terms of the total value and then dividing by 10. And so your mean would be whatever you got before plus the 3.5. The median, it won't change. The median is going to remain the same because the middle number will still be the middle number unless we changed it, but we're changing the very last number. And the question asking why does the above change affect the mean and median, so differently, it's because the mean is the sum of all of these numbers divided by 10. So if we increase the sum, we're going to increase the mean. The median is just the middle number of our group of numbers, And so if the middle number or the two middle numbers haven't changed, then the median won't change either. And so that's the answer they're looking for 1I. And for 1J, the standard deviation, if you change the number 35 to 70, well, before when we were finding the standard deviation, we were taking the value 35 and minusing the mean. And so in that case, we would have got 10 and then squared it. And so we would have had 100 in our squared means list. If we change that number to 70, now we're going to have 70 minus 25, and that's going to equal 45. And 45 squared is going to give us 2025 instead of 100. And so we're increasing that total by that amount. And so our standard deviation is going to be increased by the square root of the difference between those two amounts. So the square root of 19,025. No, not 19,025. Sorry, 1925. So when it says, did it change much? Explain why or why not. Well, it's actually going to change quite a bit, and that's because we're squaring the difference between the values and their mean, and so if we make that difference bigger, then we're squaring an even bigger number, so we're going to be making quite a substantial difference to our standard deviation. So the questions here are more of the same, really. We've just got two sets to work with instead of one, like two sets of numbers. We've got the math and we've got the English. So we're going to add up all of the math scores and we're going to divide by how many scores there are. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So when you add up all of these scores, then you're going to take that and you're going to divide by 20 to get your mean there. For the English scores, you're going to do the same thing. You're going to add up all the scores and you're going to divide by 20 to get the mean there. And so you'll have two different means to work with. When you're doing the standard deviation, you're going to do it exactly the same way that we did it on the first page. So for math, you're going to set up a chart. You're going to have all of your x values, like all of these values here in your first column. And then you're going to take your value minus the mean in the second column. And then you're going to square that answer in your third column. And your standard deviation, again, is just the sum of all of those. And then divide by 20. And then square root. Okay, they want you to do that for English and for math. And so that's going to take you through most of the questions at the bottom here. Let me just see if there's anything else. Okay. Briefly comment on the difference in means and standard deviations for either class. And so they just want you to compare the two classes in terms of their means and standard deviation. Remember that standard deviation is how spread out the data are from the mean. And so when you're commenting on that, you might say something like, the mean of the math class was 68.1% with a standard deviation of 1.2%. Whereas the mean of the other class was 70% with a standard deviation of 2.5%. So even though the average was higher in the English class, the individual responses were more spread out from the mean than in the math class. Something like that is what they're asking you to say in your comments when you're talking about mean and standard deviation. Okay, the last part of this assignment had to do with your Z-scores, and remember we did those in data management as well. In order to get your Z-score, what's Monty's grade? Okay, so let's say that our mean was 71%, okay, in the math class. If Morty has 80, then the way we get the Z-score is we're going to take Morty's grade, we're going to minus the mean grade, and we're going to divide by the standard deviation. So let's say that was 1.5 or something. I'm just making up these numbers because we didn't calculate them. So whatever Z-score you get when you do this math, so this would be 10 over 1.5, whatever that comes out to, that's what's going to go here. And then you're going to do a separate Z-score for the English because his score is still the same. He got 80, but maybe the English average was 71% and the standard deviation was 2.4 or something like that. And you're going to get a different Z score. When we compare the Z scores in number 2H, then what the Z score is telling us is how far Morty is away from the average of the whole class. And so the larger the Z score, the higher he is from the average if it's positive. The smaller the Z score, which would make it a negative Z score, the lower he is from the average. And so you're going to make comments based on whether he's above the average or below the average and which one he's more above. For question 2, the course that Morty performed better in is going to be the one with the highest Z score, okay? Because that means that he's that much higher than the class average as long as the Z scores are both positive, as long as he's above the class average. And I think he would be with a grade of 80, probably above the class average in both groups. So, more Z scores. If we go down to number 3, and this again is stuff from data management that you might remember. I think it'll come back to you a little bit as you're working through this stuff. So we have a mean of 5 seconds. Whoops, sorry. And an SD of 1.6. And this is our raw score because this is just a single data point, the 3.25. So to convert to a Z score, we're going to take 3.25, we're going to minus the mean of 5.00, and we're going to just divide that by the standard deviation, 1.6. And so here you end up with 1.75 over 1.6, so your Z score is going to be just a little bit over 1. And that's all they're asking you to do in that question. Okay, for the next one, same thing. Oh, okay, not the same thing. All right, they're giving us the Z score, 1.23, and they're giving us the mean, which is 3.47, and they're giving us our standard deviation of 2.14. So when we put that into our Z score, Z equals X minus the mean over the standard deviation. So we're going to solve this equation like a linear algebraic equation. We're going to bring the 2.14 over here and multiply it by 1.23. And then we will bring the negative 3.47 over and add it to that answer. And that will give us the X value that comes out of this equation because they gave us the Z value. All right, for question 3C, we are given a mean of 3.47, a standard deviation of 2.14, and a Z score of 0, and they're asking us to convert that to a raw score. Well, that makes it pretty easy because if our Z score is 0, it means that the difference between our score and the mean score has to be 0. So they have to be equal. And so in this case, X would have to be 3.47 so that we can do 3.47 minus 3.47 on top and get 0. The last question on this page, they're giving us a mean of 3.47, standard deviation 2.14, same as the last question, and then they're asking us to convert to a negative 2.08. So that's our Z score, negative 2.08. And then we have X minus 3.47 over 2.14. So we're going to multiply 2.14 up here by the negative 2.08. That's going to give us negative 4 point something. And then we're going to bring over the 3.47 and add it to that answer. And so our X value is probably going to be a negative value here, but that's okay. Okay, and the final page, still more Z scores. Okay, so what they're doing here is comparing two different groups. So the average or the mean weight is 1.76 with an SD of 1.01. That's for the smallmouth bass. So let's put smallmouth bass, SB, here. And then we've got muskie. So I guess we'll use an M for muskie. And the mean for the muskie is 12 pounds with an SD of 4.66. And this one was 1.76. And this one was 1.01. Okay. So now this girl comes along, and Svetlana is her name, and she catches a bass, that's 3.61 pounds. So her Z-score is going to be 3.61 minus the mean, which is the 1.76, divided by the SD. For the muskie, her Z-score is going to be, how big was the one she got? 14 pounds. The average is 12, and the standard deviation is 4.16. So when you do the math here, what's going to happen is this Z-score is going to be larger than this Z-score. This one's going to be about 2, this one's going to be approximately 2, and this one's going to be approximately 1/2 or 0.5. And so they're asking, when you filled in your Z-scores, they're asking which one she should be more proud of. And that's this one, because she's so much higher than the average weight of the smallmouth bass being caught that she should be more proud of that one than the muskie. Okay, the very last question, and again, you'll recall this from data management. Just move this up so I can draw a little bit here. Okay. In data management, we spend a lot of time looking at the normal curve. And the normal curve, the way it's set up, is at 0 standard deviations from the mean. We're right at the mean. And in this case, for the IQ chart, it's 100 is the mean value. 1 standard deviation away, which is a Z-score of 1, is 15. And so that would make this score 115. It means we go up 15 points to get 1 standard deviation away. And the same thing going down. If I have a Z-score of -1, it would be 15 less than 100, so it would be 85. And it keeps going like that. So we can do our Z-score of 2, our Z-score of -2, and then 3 is pretty much as far as we go, because we're pretty much not really exactly at the end of our curve, because it never actually ends, but we're almost to the end of the curve. We've got almost all of the possibilities included. So if I was putting numbers on these, I would be adding 15 each time. And so here I'm going to be down at 70, and here I would be at 55, okay? There's a rule called the empirical rule, and it tells us how much of the population fits in between all of these lines that I've drawn on this normal curve. For instance, anything that's between -1 and 1 standard deviation away from the mean, 68% of the population fall in that range. If I go out to 2 standard deviations, so that's either -2 or up to +2, then that percentage changes to 95%. So if I go all the way out to 2 standard deviations from the mean, that's 95% of the population. So that just leaves 2.5% over here in what we call the right tail, and 2.5% in the left tail over here. And so we can use this empirical rule. This is what it's called, empirical rule. You can look that up. Or there's also, I've got a little explanation thing about this on the Academic Skills webpage of the Trent website. If you go there and you look at math resources, you'll see the statistics basics there, and this is part of it. Okay, what percentage of the distribution is above a z of minus 2? So that's pretty easy because we know it's 95 from here to here, and then we know it's another 2.5 to the right-hand side. So that makes 95 plus 2.5, so that makes 97. Oops, 97.5%. Sorry, learning how to write with the new stylus. All right, what percentage of IQ scores is between minus 1 and 1? Well, that was our 68%, right? Between minus 1 and 1, so that's just 68. What percentage of the distribution falls below an IQ score of 115? So we have to find that up here. There's 115. So we've got the whole bottom half of the curve here. That's 50%. And then we have the space in between this line and this line, which we know has to be 34%, because 34 and 34 would add up to 68. So we have 50% for the bottom half of the graph, plus 34%, so that makes 84%. Oh, below, sorry. Oh yeah, no, that's right. Yeah, below, so to the left of. And then what's the IQ score that only 2% of the distribution fall below? I think we're calling ours 2.5. Some rules call it 2, so I think what they're referring to there is the z equals minus 3 level, and that would be an IQ score of 50. So I hope that helps. If you want to have a look at that sheet that I've got made up on the Academic Skills website, I'll try to send you a link to it if I remember. It explains all of this, so you can read through it. I know some people don't have the textbook yet for this course, and that's been a little bit of a roadblock to learning this stuff if you haven't got it. So that might help fill in some of those gaps if that's the case for you, okay?